I'm just gonna go over this homework assignment. Follow at your own pace. So first one, find an for the geometric sequence. Now again, we need the formula for geometric sequence, which is an equals a1 times r to the n minus 1. So let's start with that. So an would equal a1, which is 2 over 9, times r, 3 to the n minus 1. Now this problem wants us to find the nth term, so in this case the 7th term. So if I do a7, I just plug 7 in, 2 over 9 times 3 to the 7 minus 1, or 3 to the 6, and then I get my answer, which I don't know off the top of my head, but I have a calculator. Using that, we get 162. Okay, the next one. Right, so same idea, and actually the same term, just different a1 and different r. So just doing that again, my a1 now is 2,400, and my r is 1/4 n minus 1. So in this case, we want to plug in 7. So the 7th term would be 2,400 times 1/4, 7 minus 1. Again, I'm just use my calculator for that. So 2400 times 1/4. It's the 6th power or the 7. I'll put to minus 1 just to be safe. But I know 7 minus 1 is 6. Trust me. So I get about 5.85937. So it's a big decimal. You could try to make it a fraction. Let's see if that's nicer. Either way works. So 0.5859 ... or 75 over 128. Okay, let's move on. Write an equation for the nth term for each geometric sequence. So it's a little different. They don't want us to find the term, they want us to find the equation. So we're going to start with the same way. An equals a1 times r to the n minus 1. But now we're just going to fill out the equation. So I'll write that down here. My a1 is 8. So an, because again we're not finding terms to make all n, is 8. My r, so now r is a little trickier. There's no formula directly to find r like that's given to you, but I do expect you to know the easiest way to find r is a2 over a1. And technically it's an plus 1 over an. That just means you get a term and you put it over the term before it, and then you get the r. So a2 over a1, a5 over a4, yada yada. So here, my r would be a2 over a1. Say a1's here, a2 is here, second term. So I just put 2 over 4, 2 over 8, and I get 1/4. So they're multiplying by 1/4 or dividing by 4 every single time. So right, 8 times 1/4 is 2. That times 1/4 is 1/2. And minus 1. And there we go. That's a problem. I do the same thing over here. So same formula. And the only that's tricky is r, so we're going to find that first. R is negative 96 over 288. And actually that's a little harder for me. I'm going to do this guy over this guy. It's a little simpler. So 32 over negative 96 should be the same thing. I believe that is 3, 1/3, negative 1/3. Right, if I reduce that, divided by 2, divided by 8, in this case divided by 32, and you get just 3. So negative 1 over 3, because there's a negative. So that's my r. You can also put in your calculator if you need to. So my formula is going to be an equals a1, very first term, 288 times negative 1 over 3 n minus 1. So remember, just find a general term. So it's just n minus 1. Next one. So this is my a1, my a2, a3. My r is a2 over a1. So 6 over negative 3, which is just negative 2. So we're multiplying by negative 2 every single time. So my formula, right, since we're doing geometric, it's this formula. I just get an equals a1, which is negative 3, times r, which is negative 2, to the n power, n minus 1 power. There we go. Now we get to the little tougher ones. a3, r equals 2. Remember what I always say. Let's write down our formula first. So there's my formula. What are we missing? We're missing a1. So obviously we're missing something. We always go back to the original formula again. We go back to this guy and put it on the side here. And plug in what you know. So we're going to go back here and we're going to plug in what we know. I know r is 2. And I know the third term is 28. So when I plug in 3, I get 28. right? So that's what this means. When you sub in 3 for your n, you get 28. The third term is 28. So 28 equals a1 times 2 to the n minus 1, 3 minus 1. So I get 28 equals a1 times 2 to the squared. So 28 equals a1 times 4. 2 squared is 4. So divide by 4. a1 equals 7. So my first term is 7. So now I can plug everything in, because remember all I want is the formula. So here's 7 times my r, which is 2, to the n minus 1. So there we go. So again, with that one, I didn't have the first term, so anytime you're missing first, you go back to the original equation, and you plug in what you know. So I know when I plug in 3, I get 28 as my an, or as my a3 technically. My r is 2. Just and solve. So we're going to do the same thing here. First, I'm going to write the formula. That's the wrong formula. That's it. Oh, sorry, I was writing the arithmetic formula for a second. Rn minus 1. So again, I'm missing a1. So I have to write the formula out. So anytime you're missing something, you go back to the original formula and plug in what we have. So I have r is 1/3. I have the fourth term is 28. So when I plug in 4, the fourth term is 24. Well, I said 28 earlier, I don't know why. 24. So a1, 1/3, 4 minus 1. So 24 equals a1 to the 1/3 cubed. That just goes to both of them. So 24 equals a1 times 1 cubed is 1, 3 cubed is 27. Yeah, 27. And then what we do here is we try to solve it. So multiply by reciprocal. 27 over 1. 27 over 1. 27 times 24. I wish I knew that. I'm not Art Benjamin. That's a math teacher reference. And I get 648. And then again, that's actually wasn't the question. It was write the equation. So I got to plug 648 back into here. So I'm going to get an equals 648 times 1/3 n minus 1. And what I've been neglecting this, but if you want to check your work, just see if this works. Plug in 4. Do you get 24? And since I'm here, let me just do it. So 648 times 1/3 to the, there we go, 4 minus 1. That should get 24. And there we go. Okay, let's move on. Find the sum of each geometric series. Now, so sum is a different equation. Sum formula is Sn is a1, 1 minus r to the n, all over 1 minus r. So that's the sum form for a geometric series, the different for arithmetic series. So this first one just wants to see if we can plug it in correctly. So I want the sum of the first 9 terms. So a1 is 16, 1 minus 1/2 to the n power, so 9, all over 1 minus 1/2. If you want to simplify it a bit, like this is 0.5 on the bottom. Other than that, though, you can just sub it into your calculator. I will use the alpha y equals button to make a fraction. And I get 16, 1 minus 1/2 to the 9th power, all over 1 minus 1/2, or just 1/2. So I get 31.9375. And again, if you want, try to make it a fraction, you hit math, hit fraction, hit enter, and you get 51 over 16. Either answer is the same to me. They're equivalent, so whatever you prefer. So let's just make sure we now plug it in. So let's do the next one. So exact same idea. So we want to find the sum of the first 8 terms. The n is 8. So just plug into this formula here. So the first term is 36. 1 minus r is 1/3 to the n to the 8th power, all over 1 minus 1/3. Then again, we just go back to our calculator, plug it in. So 36, oops, sorry, it's a lot easier with the with the special button, so I don't have to worry about putting parentheses everywhere. Use the technology that we have. 36 to the 1 minus 1/3 to the 8th power, and then you divide it by 1 minus 1/3. So 53 point blah blah blah. Or as a fraction, might be a little nicer in this case. Or just as disgusting. So there we go. Next one. It's in the summation form. So remember, when you see this notation, that means find the sum. The difference between this one we did last time, this is in geometric form. So if I was doing this geometrically, I'll go, I need to find my, right, so if I'm use the formula, which is this, I need to find A1 and R. Now here's a little hint. Look at this guy. That's like our basic formula. Geometric formula. A1 times R to the n minus 1. A1 is this guy right here. R is this guy right there. What is my n? Well, I'm going from 1 to 8, so it's going to be 8. Right, now it sounds like you don't subtract them because that'll be 7. It's always one more than that. It's just 8. So how many terms are we counting? We're counting 1 through 8, so that's 8. And if I want the sum of this, I can just plug it into here. So I'm finding the 8 terms. My first term is -3. 1 minus -2 to the 8th term, all over 1 minus -2. Again, I could type that into my calculator. So alpha y equals, we get -3 times 1 minus -2. Make sure you put this in parentheses because it does matter, to the 8th power. In this case, it'll just be a positive value because it's an even power. All over 1 minus -3. So you can write that, you can just put 3. I'm going to go brave into the good night, -3. And you get 255, right? Because what happens, these cancel out and you're just really doing this right there. So you get 255 is the sum of the first 8 terms of the sequence. Now, if you've been in my class before, you know there's also another way to put the summation to your calculator. So if you go math, and all the way toward the bottom, there's a summation value. And you can also plug it in this way. So we'll just use any variable. I'll just use X for my variable. And then 1, then 8, and then -3 times -2 to the x minus 1. Hit enter, and you get 255, the exact same answer. So 2 is to do it. Next one, find A1 for each geometric described. So they give us the sum this time, and they want you to go back and find A1. So in this case, it's going to be the summation equation to Sn is equal to A1, 1 minus R to the n, all over 1 minus R. Now, sub in what we know. R is 4, N is 7. Sn is -10,922. So I'm going to simplify this round down a bit. I'm going to get -10,922 equals A1 to the 1 minus 4 to the 7th, all over 1 minus 4 is just -3. So that's just an algebra problem. I'm going to simplify this right here. Let's get rid of the -3. I'm going to times both sides by -3. So these cancel out. I get that times -3, which again, not Art Benjamin, not a math magician. So -3 times, there we go, there's times -10,922. And I get 32766 equals A1 times 1 minus 4 to the 7th. Now I'm just going to divide by 1 minus 4 to the 7th, which is some big number that I don't know. I think Art Benjamin might actually have a problem with that one. Yeah, I've said his name a lot. Look, Google him. YouTube him. Some fun math stuff. 32766 divided by parentheses 1 minus 4 to the 7th. Hit enter and you get -2. there's what A1 is. Let's move on to the next one. So same question. Someone go s to the n equals a1 1 minus r to the n all over 1 minus r. Remember, they don't have to give you these formulas. It's like they do in IB. So you have these formulas where you decide how to use them. Sub in what we know. This is negative 2912. R is 3. And n is 6. So I'm going to rewrite that. So like that. Simplify it a little bit. So this right here is negative 2. Let's get rid of that fraction. Multiply both sides by negative 2. So I'm going to get 4, 2, 8, 5, 5, 8, 2, 4 equals a1 times 1 minus 3 to the 6. I think that's right. And then we're going to divide by this guy. So 1 minus 3 to the 6, divide both sides by that. I'm not going to try to do this one in my head. So a1 equals, let's use my calculator. So 5, 8, 2, 4 divided by 1 minus 3 to the 6. I get negative 8. Boom, boom. So that's how you do those. So we'll move on to the next one. Determine whether each infinite, probably helps if I take that away. Determine whether each infinite geometric series is a convergent or divergent. So it's like a definition. So first, infinite geometric series. Those are geometric series that go on forever. It's like here, the dot, 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 the ellipses. Right? Now geometric we know is when you multiply or divide to get to the next term. And then is it convergent or divergent? So very simple. Slow definition. It's not. R is, if R is greater than 1. Actually, I have it wrong, sorry. If R is less than 1, it's convergent. If R is greater than or equal to 1, it's a divergent. Also a bad movie series. So either way, that's all it is. It's just a definition. So all you gotta do is find R. If it's less than 1, it's convergent, which means that there is a sum to it. You can find an infinite sum. Numbers keep on getting smaller and smaller, so you can actually add them all up. And divergent means there's not an infinite sum. You can't do it. Numbers get too big. So if R is greater than or equal to 1, then it's divergent. Remember the way we find R is an plus 1 over an. Easiest way to think about that is a2 over a1. It's just one term over the term before it. That's all it is. So let's do these. 16. So here's a1, here's a2. My R would be 63 over 21. I don't even know what that is. That's bigger than 1. R is greater than 1, so this is a divergent sequence. The next one's a little tougher. It's fractions. I guess the next one's technically this one. Let me do this one first. So my R here is going to be 360 over 480. That is less than 1, right? 360 is less than 480. So this is convergent. I could find the sum of this guy. We'll do that down here. I could find the infinite sum of that guy. Keyword is infinite. That means it's going on forever. It's not the first 10, it's not the first 20, it's forever, all of them. The next one here, fractions. So again, I'm just going to put this guy over this guy. So 9/8 divided by 3/4. Trick to doing these type of fractions is just rewriting it. So 9/8 divided by 3/4. And then all we do is flip the right hand side. 9/8 times 4 over 3. You can reduce things. 1, 2, 1, 3, and I get 3 over 2. That is bigger than 1, so divergent. And then same thing with this one. So I'm going to do 19, I'm going to have space here. R is equal to a2 over a1. So I'm going to put 10 over 9 divided by 5 over 6. Remember, the middle sign is just a divide sign, so rewrite it. So then I can flip the right hand side. 10 over 9 times 6 over 5. Reduce things as you see fit. And I get 4/3. So bigger than 1, so divergent. So that's all this section was. If your R is less than 1, it's convergent, which means you can find an infinite sum. If your R is bigger than 1, it's divergent, equal to bigger than 1, and you can't find it. So next I want you to if I could talk. Next, I actually want you to find the sum of each infinite series. So there's a formula for that. Special form for infinite series. It's S infinity is a1 over 1 minus r. Right? Such a simple formula. Love it. Love that formula so much. Such a simple one. Keep in mind that r has to be less than 1. Absolute value r has to be less than 1. I don't care if it's plus or minus, if it's less than 1, if the absolute value, if it's less than 1, and then it's convergent. And you actually could do this. So the first one here, let's find our r. First thing I do is find this. And again, I'm just going to put the second term over the first term. So negative 8 over 16 is negative 1/2. That is less than 1. Remember, the absolute value of r is less than 1, so this is convergent. I can find an infinite sum. All we can do is plug into that formula. So my first term is 16. My r is negative 1/2. So do some math. I could put that in my calculator, but come on. We should be able to do this. Common denominator is 3/2. That's a divide sign, so 16 divided by 3/2. Sitting is saying 16 times 2/3. So I get 32 over 3. That's an infinite sum of this, which is kind of crazy. Remember, all we're doing here is adding 16 minus plus negative 8 plus 4 minus 2 plus 1, on and on forever. And then you add them all up, you get 32 over 3. Kind of ridiculous. Next one. So again, this is our formula. First thing you want to find is your r. So in here I get negative 48 over 32. Now again, I don't care about the sign. The sign does not matter to me. So this is a number, physical number bigger than 1. In this case it is. 48 is bigger than 32. R is greater than 1, so it's divergent, so I cannot find it. Not possible. So does not exist. The infinite sum does not exist there. Next one, same question. First find your r. I get 40 over 32. So again, r is bigger than 1, it's divergent, it does not exist. There's no infinite sum for that one. The next one, it looks like my r is going to exist. I get 14 over 21, so I get 2/3 divided both by 7. So r is less than 1. I could do this one. It is convergent. So this one do the sum. S infinity is a1 over 1 minus r. Such an easy formula. 21 over 1 minus 2/3. Common denominator, so 21 over 1/3. So this is saying 21 divided by 1/3, or 21 times the reciprocal. So I get 63. Now we can also see in this form, right? So look at it's a summation, infinite summation, so same question. If you notice this the way they're in this form, this is in the geometric form. You see a number to a power, that's an exponential, it's a geometric form. So here, as we talked about before, a generic geometric sequence is like this. This is my a1, this is my r. What do you notice here though? R is bigger than 1, so it's divergent again. It does not exist. You cannot find an infinite sum. The one right here, here's my a1, here's my a2, here's my r, sorry. R is less than 1, so this is convergent. You could do it. So all I can do is use my formula. S infinity equals a1 over 1 minus r. A1 would be the first term here, 8/3. R would be the guy right here, 5/6. So I got 8/3 over 1 minus 5/6. Again, if I want to put my calculator, just remember if you're doing that, it's a lot easier if you use the alpha button. Well, I'm gonna do it. Not gonna conform. Common denominator is 6 over 6. I got 8/3 over 6 over 6 minus 5/6 is 1 over 6. That's a divide sign, so 8/3 times the reciprocal. So look at that, I'm just gonna skip a step. Right, instead of dividing by 1/6, which is what it is, I just already skipped down and went to multiply by 1/6 over 1. Reduce, I get 16. Look at that, it feels so good doing it by hand. Feels great. No calculator needed. Next, fan. The fan is running at 10 revolutions per second, and it is turned off. Its speed decreases 75% per second. Determine the number of revolutions completed by the fan after it's turned off. So it's kind of a weird question. This is a geometric sequence because it's losing by a percentage. What they're saying here is this is your R. Your R is 0.75. And you started off at 10 revolutions per second. So that's your A1. And what it wants to know is how long does it take to turn off. So we're going to keep on going forever until it turns off. So this is actually a fancy way of doing an infinite sum. That's all this is. You're saying, hey, we're starting at 10 revolutions per second. That's when we're starting. I turn the fan off until it stops. So it's going on forever. And then every single time I do the 75, it decreases at a rate of 75%. So you only get to keep 75% of your value. So that's your R. So we just unplug it in. So 10 over 1 minus 0.75. That's 10 over 0.25. Now 0.25 I know is a fraction, it's 1/4. So if I'm doing this all by hand, I'm going to say, hey, it's essentially saying 1/4. Hey, that's a divide. So 10 divided by 1/4, or 10 times the reciprocal. So 40. So that's the idea. Now again, it's a little weird, but it's just kind of understanding that they mean infinite sum when they're talking about this. Since we're going, hey, we're going to see how long it takes until it stops. They're going off, so they mean pretty much in forever until it stops. So infinite sum. So next one, the virus goes through your computer infecting the files. If one file was infected initially, and the total number of files infected doubles every minute, how many files will be infected in 20 minutes? So now this one's not an infinite sum, it's for the first 20 minutes. So that's my n is 20. A virus goes through your computer infecting the files. If one file was infected initially, that's my A1 is 1, and the total number of files infected doubles every minute, so that's my rate. R is 2. How many infected in 20 minutes? So again, if it said how many infected forever, then n is whatever. Then infinite sum. But in this case, it said in the first 20 minutes, so I have my n's 20. So again, it's a number, how many files will be affected in 20 minutes? So the question here is, do I do infinite, do I do sum, or do I do term? Now, how many files will be infected? I think the implication here is, it sounds like they want how many total files are infected in 20 minutes. So I'll do the sum for the first 20 minutes. If they want how many files are affected in the 20th minute, then they'll just do a term. So it's a little funky, but the general implication is the sum. So they want you to do this. Sn equals A1, 1 minus r to the n over 1 minus r. Subbing everything in. So that's 20 and 20. R is 2, and my A1 is 1. So I get 1 minus 2 to the 20th term, which I have no idea what that is. 1 minus 2. So I'm going to plug that into my calculator. So I get, let's do, oh, I already have it. So 1, I didn't need to put the 1 there. What am I doing? 1 minus 2, so the 20th term. Go, and then over 1 minus 2. So hence the negative 1, but whatever, I'll just put it in. And we get a lot of files. So about 1, 0, 4, 8, 5, 7, 5. So over 1 million files. But that's the answer. Next one. The first swing of a pendulum travels 30 centimeters. Hey, that's my A1. Each successive swing travels 95% as far as the previous swing. So my R right there is 0.95. That's the rate. Find the total distance traveled by the pendulum at the 30th swing. So there's my n, 30. And again, total distance, so it's a sum. I'm using the sum form, not the term formula. So, just run it back, do it again. Sn equals A1, 1 minus r to the n, all over 1 minus r. So I get 30, 1 minus 0.95 to the 30th, over 1 minus 0.95. So that one I'm definitely using a calculator on. I wish my practical math was that good. So let's do alpha y equals, I got 30 times 1 minus 0.95 to the 30th power. So 95% to the 30th power. And then over 1.9.95, which is just going to be 5%, but I'll do this just to be safe. And I get 471. Math fractions to see what that is. As a fraction, no fraction form. So that's a rational. That's an irrational number. So about 471. That's my answer. Okay, let's do a 10-1 review, because that's what I have here. So I'm going to do it. So remember, in 10-1 was about geometry, or 10-2 technically, that's a little typo. It's arithmetic sequences, that's what 10-2 is all about. So given this, let's find, so given this sequence here, just arithmetic sequence, let's find A10. Remember, arithmetic sequence when you add a term every single time. So you're adding and subtracting. But to find A10, I just plug 10 into the equation. So A10 just equals 3 times 10 plus 4. So 34. If AN equals 70, find N. So I know an equals 70. So 70 equals 3n plus 4. Then when you find n, so to solve for it, subtract 4. I get 66 equals 3n. Divide by 3. N equals 22. Just like that. Find the sum of the first 10 terms. So we have a formula for that. The summation formula for arithmetic sequence is an. Now there's two of them, and that's actually the wrong formula. N over 2, a1 plus an. That's the first one, which was actually I'm not the biggest fan of. It works here. I can do it here. Or you could do the other one, which I usually use more of, which is n over 2, 2a1 plus n minus 1 times d. Now in this case, actually, I would say this one does work a little better. It's a1 right there. a1, I don't have a1, but I can find a1. Plug 1 into this function here. a1 would be 3 times 1 plus 4, which is 7. an, or in this, sorry about that. Let's just simplify this a little bit. I'm looking for the sum of the first 10. So it'll be 10 over 2, a1 plus a10. That's what I'm looking for. Now, watch out here. A lot of people put 10 here, and I hate that. It's not 10. N is 10, not 8. This is a temp term, not 10. So a1, remember if you want to find a1, you just plug 1 into the equation. So 3 times 1 plus 4 is 7. a10, we actually already found already, is 34. Notice how it's not 10, it's 34. The temp term of the sequence is 34. Simplify this is 10 over 2 times 41. So I get 5 times 41. So I get 205. And that's that problem. Find the sum of the arithmetic series. Now it's an arithmetic series. Remember the sum of that. Sum formula for that. We just talked about it. There's these two formulas. It's either this guy or it's this one. Like that. Now in both cases, notice the hint there. I don't have n. I have a1. I could find d if I want to find d. What I don't have is n though. So I gotta find n first, because n's missing. Remember what I always say, if something's missing, go back to the general term formula and plug in what you know. So for an arithmetic sequence, that is this formula. I know we've been doing geometric, but this is an arithmetic sequence one. Then plug in what we know. I know the first term is negative 15. I don't know what n is. I do know what d is. D is, what are we adding every single time? 4. 4 plus 4 plus 4. And then I know what an is. An is always the last term. So an is that. So this is 53. Now let's simplify this. Or let me rewrite it first. I'm going to solve for n. So add 15. I get 68 equals n minus 1 times 4. Now you can distribute the 4 if you want. I think it's a little easier if you divide by 4. And then here I get 128, so 7 equals n minus 1. And then we just add 1 to both sides, and n equals 18. Now I'm all proud of myself, I got n equals 18, but that's not the question. The question is find the sum. So you gotta find s of 18. Now we can just use this formula. So it'll be 18 over 2. The first term is negative 15, plus the last term. Remember, it is not 18, that's not n, it's an. And an is 53. So if I simplify this, I get 9 times 53 minus 15. So that's 43 minus 38. And then that's me 38 times 9. I wish I knew that off the top of my head, but I don't. So let's go 72. 27 plus 7. So 34. 342. There you go. That's it. That's everything. Hope that helped.